In a previous video, we've introduced ourselves to the idea of an orbital, that electrons don't just orbit a nucleus the way that a planet might orbit a star, but really, in order to describe where an electron is at any given point in time, we're really thinking about probabilities, where it's more likely to be found and less likely to be found. And an orbital is a description of that. Where is it more or less likely to be found? And this diagram shows us the types of orbitals which can be found in the various subshells which are found in the various shells. So you have the S subshell, the P subshell that has 3 different orbitals in it. You have the D subshell that has 1, 2, 3, 4, 5 different orbitals in it. And then you have the F subshells. Now, each orbital can fit 2 electrons. So if you're thinking about the subshell, the S subshell can fit 2 electrons. The P subshell can fit 6 electrons. The D subshell can fit 10 electrons. And the F subshell can fit 14 electrons, 2 per orbital. Now, the goal of this video is to think about electron configurations for particular atoms. And to help us with that, we will look at a periodic table of elements. And so first, let's just think about the electron configuration of the simplest element. If we're talking about a neutral hydrogen atom, it has an atomic number of 1, which tells us that it has 1 proton. And if it's neutral, that means it has 1 electron. Now, where would that 1 electron be? Well, it would be in the lowest energy level, or the first shell. And that first shell has only 1 subshell in it. It only has 1 type of orbital. It only has an S subshell. And so that 1 electron in that neutral hydrogen atom would go over there. So we would say its electron configuration is 1s1. In the first shell, which is made up only of an S subshell, it has 1 electron. Now, what happens if we go to helium? Well, a neutral helium atom is going to have 2 electrons. So instead of just having 1 electron in that first shell, we can fit up to 2 there. So its electron configuration would be 1s2. Now, what do you think is going to happen when we go to lithium? Well, lithium, a neutral lithium, will have 3 electrons in it. So the first 2 could go to the first energy level, the first shell. So the first 2 will go 1s2. And then the third electron is going to go into the second shell. And the subshell that it's going to fill first is the S subshell. So then it'll go to the second shell and start filling up the S subshell. So notice, 2 electrons in the first shell and 1 electron in the second shell. Now, what about beryllium? Well, that's going to look a lot like lithium, but now it has 4 electrons. So 2 of them are going to go into the first shell, 1s2, and then the next 2 are going to fill up the S subshell in the second shell. I know it's a bit of a mouthful. 2s2. Notice we have 4 total electrons, which would be the case in a neutral beryllium atom. But what about boron? Boron gets interesting. A neutral boron would have 5 electrons. So the first 2 are going to fill the first shell, 1s2. Now the second 2 are then going to go to the second shell and fill up the S subshell, 2s2. And then we're going to start filling up the P subshell. So let's see, we have 1 more electron, so we go 2p1. So you're going to have 1 electron in one of these p orbitals. And then what happens when we go to carbon? Well, it's going to look a lot like boron, but now we have 1 more electron to deal with if we have a neutral carbon atom. It's going to have 6 electrons. So that extra electron is once again going to fall into the P subshell in the second shell, because that can fit 6 electrons. So we're going to fill the first shell with 2 electrons, then the 2s subshell with 2 electrons, and then we have 2 more electrons for the 2p subshell. Now you can imagine as we get to larger and larger atoms with more and more electrons, this can get quite complex. So one notation folks often use is noble gas configuration, where instead of saying, okay, this is carbon, they could say that, hey, look, carbon is going to have the electron configuration of helium. Remember, the noble gases are these group 8 elements right over here. So it's going to have the electron configuration of helium, which tells us this right over here. And then from that, we're going to also have 2s2, 2s2, and then 2p2. you could just take helium's electron configuration right over here and put it right over here, and you would get exactly what we wrote before.